Okay, welcome everybody to this webinar about the OCPP 1.6 Security White Paper, or its official name, Improved Security for OCPP 1.6-J. The agenda for today, I'll start with a short introduction, give some background about the Security White Paper, and then go to the details of it, starting with the secure connection setup, discuss the security events and logging, secure firmware update, and before the questions, I will go to the minor differences between edition 1 versus edition 2, for those that are already familiar with the old version. Shortly about me, my name is Paul Klapwijk, working as an IT architect for the Open Charge Alliance. One of my main tasks is that I'm the chair of the compliance working group that's responsible for the certification program and the OCPP compliance testing tool. So about the security white paper, just a little bit of history of OCPP. For those of you not familiar, it started all in 2009. You can see here the different versions that have come across during the last years. And in 2018, we released OCPP 2.0, which included the first version of security, including all use cases to support security profiles. And we decided that it was an important topic, and we decided to port it back to OCPP 1.6. So later that year, we introduced the OCPP 1.6 Security White Paper, the first edition. And this year, in March, end of March, we released OCPP 2.0.1, which is a maintenance release. And we also had some minor changes to the security, which we also included in the OCPP 1.6 Security White Paper, which resulted in the Security White Paper Edition 2. So I will mainly focus on the Edition 2 today. As I said, I will also have a short look at the differences between the previous edition. About the white paper, I already introduced the functionalities that are in there. There's a number of connection profiles, certificate management, security events, and secure firmware update. And the title of the presentation already included 1.6J. It's JSON only. And if you want to acquire the white paper, you can go to our website. And if you go to the protocols menu and then to the info and white papers submenu, you can download it there. The direct link is also here in my slide. For those of you that are familiar with OCPP 2.0 or 2.0.1, the use cases that are written down in OCPP 2.0 are also included in the OCPP 1.6 white paper. So the actual use case numbers are also included in the chapter name. So the different functionalities you see here, which we will come across today, they are all related to the use case numbers, which you can find also in OCPP 2. So let's dive into the details. The first topic is the secure connection setup. We have defined 3 different profiles. So I will start off by introducing those security profiles. And to support these profiles, we have a number of use cases that are used for the basic authentication password update and also for certificate management. I'll first introduce the different security profiles, and then afterwards I will describe the supporting use cases to be able to use profiles. The security profiles. So these were the input and the review for these security profiles were done by the European Network for Cybersecurity, ENCS, and the Radboud University in Nijmegen. And we came up with 3 different secure connection profiles. You see them listed here. The first one is unsecured transport basic authentication. The second one is transport layer security with basic authentication, TLS. And the third one is TLS with client-side certificates. So I will come across all of these 3 in the next slides. So the first one, the unsecured transport with basic authentication, it looks like this. So you, when looking at this, you see that you have an HTTP request which starts communication, and you give the authorization key in the HTTP header, and that consists of the charge point ID and an authorization key. The authorization key is the name for the password, separated by a colon, and these are together base64 encoded. So this is actually what you normally would use for HTTP basic authentication. Now this is combined with WebSockets. So to make it a little bit more clear how this is included, we included also an example. I showed it here on the screen. So when you start a connection, you have to send an HTTP request where you request an upgrade to WebSockets, and you also include the authorization. So you include here the base64 encoded charge point ID and authorization key. The second profile is the TLS with basic authentication. This sounds, as you can see, it also includes basic authentication, similar to the previous one, but this time the transport is also secured. We only use server-side certificates. So on the left side, you see the TLS setup. It only includes server-side certificates on the central system side. So the charge point is serving as the client and the central system is the server side. And the TLS connection is started from the client to charge point. And after the TLS connection is set up, the same procedure for the basic authentication is used, similar to the previous slide. The third profile is also TLS, but this time not with basic authentication, but using client-side certificates. So this time the central system uses server-side certificates, but the charge point also identifies itself with a client-side certificate. You can see here the more detailed communication. We'll go to more details about how to get this client-side certificate in the charge point later in the presentation. So these are the three security profiles in OCPP 1.6. And as you can see, the first two profiles both use basic authentication. Now the username for that is the charge point ID, as you have seen, but the password is an authorization key that can be changed, a password that can be changed. So we included the use case for that. So you can see here the changing basic authentication password use case. It's quite simple. We use the authorization key as a configuration key, as it's normally used in OCPP 1.6. So the change configuration request and response can be used to set this. And after it has been changed, the charge point has to disconnect and reconnect using the new password. We included a number of requirements for this that are, of course, mandatory. We also include a number of recommendations. So if you read through the security white paper, you will also see a number of recommendations of how to handle passwords. And like I said, the basic authentication is used for the security profile 1 and 2. So for the unsecured transport with basic authentication and for the TLS version with basic authentication. And then we go to the more complex part, the certificate management. As I already indicated, the profiles 2 and 3 both use TLS, and one even uses client-side certificates. So the certificate management is needed for installing certificates. Now, before going into the details of the certificate management itself, first a little bit about the certificates that we use in OCPP. These are three of the requirements that I've taken from the specification. The first one is states that all the certificates used are used in PEM format. So you can sort of rest assured that every certificate is in the same format. And the second and the third requirement both give information or state how you must use the certificate common name. So the first one says that for the central system, it should include the fully qualified domain name. And the second one says that for the charge point, the unique serial number of the charge point must be in the common name of the certificate. So these are fixed values for each certificate. Now, a little bit about cipher suites. Like I said, we use certificates for the TLS handshake to make sure that all these systems that use security are interoperable with each other. We also decided to include mandatory cipher suites. Cipher suites are sort of collections of algorithms used for setting up the TLS connection. So what we have done, we have made a number of these cipher suites mandatory, so that we are sure that each system that uses the OCPP 1.6 white paper can connect with another system. So we made on the right side, you see the central system cipher suites. We have 4. These are all 4 are mandatory for the central system. And on the left side, you see the charge point, and there you see that you have a choice. You can either support the first 2 or the second 2. Or, and that's sort of an exception we made in 1.6, is that when your charge point is not able to support TLS 1.2 because of hardware limitations or other limitations, then it is allowed to have a TLS 1.0 or 1.1. Then the cipher suite you see here below is the one that you have to support. Please note that when you do not support TLS 1.2 or higher, you're not able to go for OCPP certification. For the certification to get a security certificate, the 1.2 TLS 1.2 is mandatory. Now I marked in yellow the digital signature algorithms. It's a bit good to notice that you have to support, or on the central system side, you have to support 2 different digital signature algorithms that are used for, well, sending digital signatures. Which also results in 2 different certificates. So it's important to notice that on the central system side, you will have to have 2 types of certificates. On the charge point, you have to have at least one of the 2 to be able to connect over TLS. Now, then the next step is, of course, how to get certificates into a charging station. So we have 2 different types of certificates. The one is for setting up the server-side TLS communication with the back office. So that's where the charging station needs CA certificates to be able to verify. And the second one is to install the client-side certificates, which are only used for profile 3. So we'll first go into the management of the CA certificates, which are used for profile 2 and 3. Now, the management consists of 3 operations. We can retrieve certificates, we can delete them, and we can install them. So I'll start with retrieving certificates. It's a specific message for that. It's called get installed certificate IDs. And you can give it as an argument its type of certificate. And then the charge point has to return a list of certificates. And it doesn't return the certificate itself, but it will return an object called certificate hash data, which basically contains the hashed issuer name, serial number of the certificates, so you know which certificate are installed. The 2 types of certificates that you can you can request from a charge point are the central system root certificate or a manufacturer root certificate. The first one is used for the TLS connection and also as the root for the client-side certificate. The manufacturer root certificate, I will discuss this one later. That's used for the signed firmware update operation, but that's later in this presentation. Now, like I said, it returns the certificate information in the form of a certificate hash data. And with this certificate hash data, you can also delete a certificate. So you can, we have a delete certificate operation for that. So delete certificate.req. And the argument you can give that one is the certificate hash data. This operation cannot be used for deleting a charge point certificate itself. We have different operations for replacing that one. And it's also not for deletion of the central system root certificate that's in use, because otherwise you could result in the charge point not being able to connect anymore. So that's why it's not, you cannot use it to delete a certificate that's currently in use. Yeah, and of course, installing CA certificates. So when you, that's of course also important. So once you can have multiple certificates of the same type. So you can have multiple manufacturer root certificates for signing for signed firmware upgrades. And you can also have multiple central system root certificates, which can, for example, be used when upgrading from an old to a new certificate. Then you have to install the new one, you have to reconnect, and then you can remove the old one. The installation can sometimes lead to memory problems, especially with older charge point. So we also include a configuration key where you can indicate the maximum size of your certificate store. So then the charge point can sort of ensure that it will not be overloaded with installing all kinds of certificates. Installing a certificate, as I said, it's done by a message install certificate, and you have to not only send the certificate, but also the certificate use. So you also have to indicate for what it's used for. So now that we have the CA certificates managed, so we can use them for profile 2 and 3. The remaining operation is still for profile 3 to get client-side certificates into the charging station. We have a separate use case for that. It's actually quite, it looks complex, more complex than it might is. We actually have two. This is the one that's updating by request of a central system. It basically follows the same procedure you would normally do if you are requesting a TLS certificate from a certificate authority. So it's actually done normally when you do this, for example, as for a server, you will do this by hand. This is done from the charge point in this case, and if it's triggered by the central system, you need a sort of a trigger message for this. Now we decided not to mix this with the existing 1.6 OCPP 1.6 trigger message, but we created a new message for this, which is called the extended trigger message. And the central system can use that to trigger the update procedure for a charge point certificate. What the charge point has to do then is to generate a public and a private key pair, and then it has to request the central system to sign its certificate. The default certificate mechanism for X509 certificates can be used for that. So the charge point has to create a certificate signing request, and it has to send that to the central system. Now, one of the requirements from OCPP 1.6 security is that the organization name must include the CPO name. So we have a configuration key which you can use to set the CPO name in advance. Then the charge point can use that to create a certificate signing request. It's sent to the central system that responds that it has accepted it, and then it can, in a separate message exchange, request a certificate at a certificate authority. Can also sign the certificate itself. That's up to the implementer. And once it has a signed certificate, it can send the signed certificate back to the charge point, and there's a separate message for that. It's called certificate signed.req. As you can see here, it's sent to the charge point. The charge point first has to verify that it's a valid certificate, and then it has to respond with accepted. And once the certificate becomes valid, the charge point has to switch to the new one. So, for example, once a certificate is almost due, you can imagine that you have to update the certificate in advance. So you cannot do it once it has expired. So you have to do it in advance. So you can beforehand change the certificate, and then the charge point will switch to the new one once it's past the start time from the validity period. Well, this procedure is when the central system starts its procedure with a trigger. The charge point also can do it itself. So when the certificate is almost due, the charge point itself can also start the procedure. In that case, no trigger message is necessary, but it can just generate a new public and private key pair and request to the central system to sign a certificate using the same message exchanges. Again, with the signed certificate request. And once it's signed by a certificate authority, it can be sent back by the central system to the charge point again. One thing that is notable here is that we have created quite a large field for a certificate, because that can lead to memory problems with some charge points. We also include a certificate signed max chain size key. that key can be used by a charge point to indicate what the maximum size of the certificate chain can be, so it can protect it from overloading its memory. So once we have all these certificates installed, the final thing we have to do is be able to switch between different security profiles. You can do this quite simple by having a configuration key which is called security profile. Same procedure as we usually do with OCPP 1.6. We have a change configuration request which you can use to set the security profile. One important thing to note here is that for security reasons, it's only allowed to go to a higher security profile. So it's not allowed to go to a lower one over OCPP. It's not only via this route, but also via data transfer or other configuration keys. It's only for increasing the security profile. If you want to lower it, you have to find another way, for example, by a new firmware or another way of doing this, but this other way also has to be protected for security reasons, of course. So that's the first topic. So I hope it's a bit clear what kind of secure connections variants we have and how the use cases to support them work. Now then we have a second topic related to security, and that's the events and the logging of security events. Now we have two use cases for that. The first one is for security event notifications. And these are meant for informing the central system of critical events. It's required to queue those and to guarantee to deliver them at the central system. So it's not, so it's sort of like transaction-related message. You really have to queue them. And the second requirement is that you also have to store them in a separate security log. We'll get back to that in the next use case, how to get the security log, but it's important that you all these security events should be logged and sent to the central system. I wrote down some example security events. For example, when there's a memory exhaustion, somebody cleared the security log, then those are reasons to send a security event. We have a separate section in the security white paper where you can see the list of security events that can be used. Like I said, the security events also have to be logged. They also, and of course, then the log has to be retrieved in some way. Now we have a separate get log message for this. So we are not using the get diagnostics, but a separate get log message. This has a log type as an argument. And if you request a security log for this, it will use the same way of uploading the log file to a server, to the central system. And it also has a separate log status notification message, which it can use to indicate whether it's uploading or whether it has, and once it's done, to indicate that it has uploaded the file. So these are, and the uploading is for a single file to a specific location. So this is the way you can retrieve the log file from the charge point. Then the final functionality related to the charge point is the secure firmware update. This is quite a complex diagram, so I split it in two. It's less complex than you might think, but I will try to explain. To do a secure firmware update, there's a specific message added, a signed update firmware request. And when you send this to the charge point, you have to send the location of the firmware and some other information. You also have to send the certificate that you have used to sign it. The certificate has to be derived from the manufacturer root certificate we came across earlier in the presentation. And the first thing when you get the charge point receives this signed update firmware request, that it has to verify the certificate with its root certificate. And if it's valid, it has to accept the message and send a signed update firmware conf message back to the central system. Of course, if it's not valid, then it has to reject the message. And it also has to send a security event notification with the security event invalid firmware signing certificate. So That's the signing certificate of the firmware. That's used to verify the entire firmware. So that can be used after the firmware has been downloaded. So once you have confirmed that the certificate is valid itself, then the next step is that you have to start downloading the firmware. So there are signed firmware status notification messages to inform the central system of the progress of the firmware update. So you start off with saying to the central system that you're downloading it. Once it's downloaded, you can say that it's downloaded. You can see that here in the status. For those of you that can read, this text is here. And once you have downloaded the entire firmware, you have to verify the signature on the whole package. And once that is done, you can notify the central system of that the signature is verified, and then you can actually start installing the firmware. Now, the next part of the diagram is quite complex, but it's actually a bit complex way of writing it down. So it's because the order of installing and rebooting is not fixed, and it's also not mandatory to do a reboot. So that makes this picture quite complex. But the main idea is that once you have verified the signature, you can install the firmware, and based on your implementation, you can reboot the charge station or not. Now, of course, during this whole process, many things can go wrong. So we also included a small process diagram in the specification where you can see the different steps that you can go across and also the errors that can occur. So also a number of error states. I wrote down a few of them. So for example, the download can fail. So then you have to send a signed firmware status notification with the status download failed. You also can have an invalid signature, which has to be accompanied with a security event, and the installation itself can, of course, also fail. Then a final note on the edition 1 versus edition 2. As already indicated in the beginning, the OCPP 1.6 Security White Paper has been based on the OCPP 2.0 implementation for edition 1. The edition 2 has been based on the OCPP 2.0.1. The main changes are in the fact that all messages now use PAM encoded certificates. Some field names have changed for clarification, and we also added a number of requirements, especially related to the signed firmware update, because as you have seen, I went over the basic process, but we have a lot of requirements accompanying the signed firmware update process. And finally, the edition 2, so the latest version, that's also part of the certification program. So you can get a separate security certificate for this version. So if you have implemented this, you can go for certification. And for those of you that also have the OCPP compliance testing tool, the edition 1 was originally supported in the version 1.3. Edition 2 is now supported in OCPP 1.4. So for those of you that haven't done already, if you have the OCPP compliance testing tool and you want to test security, please update to the latest version. Then you can test the latest edition 2 version. That's it from my side for now. So it's time for questions.
Thank you, Paul. Great presentation. I would like to ask Milan to join us in answering the questions. Maybe he can fill in some more technical questions. Milan, are you ready?
Yes, I'm ready, Martijn.
Sorry. Is your video working? Yes, here you are. Welcome again. We have some questions coming in. First was the first part of the presentation. Are these use cases also testable with the OCT?
Yes, the different use cases from the security white paper are also included in the test tool. Yeah.
Okay. Let's see. Is it allowed for a backend to limit the certificate signing to, for example, once a day or week?
I can answer this one, Paul.
Okay.
The OCPP specification requires that the charging station will have to refresh its client certificate 1 month before the current one expires. So that's a hard requirement. And the CSMS can trigger whenever it wants to refresh the client certificate. So that's in the discretion of the CPO if you want to replace it at an earlier time.
Okay. Let's see. Can the central system also act as a certificate authority?
Yes, that is possible. Of course, it's always up to the implementer to decide what you think is secure enough for your implementation. But if you are a central system, you can, if you want, you can sign the certificate yourself with your central system root certificate. Yes.
Okay. Let's see this. When using SFTP for firmware updates as recommended, how do you suggest to safely provide username and password for access, as this is, as far as I know, mandatory for SFTP? Besides including it in the URL, little bit of code, username, password scheme, as this seems not safe.
Yeah, good question. It's not really inside of the scope of OCPP, but if I remember correctly, as you're mentioning including it in the URL, yes, this is not safe, but I think it's also deprecated now. So it's also not the way it's supposed to work anymore. But Paul, I'm not sure if you know how you should make this work.
No, I have to get back on this one.
Okay. And as I have said, we are trying to answer all questions, but we will be logging all questions we have coming in, and we will use our email or our website to answer questions we can't answer right now. Let's see. Are edition 1 and 2 testable with OCPP 1.4?
The edition 2 is testable with the OCPP 1.4. The edition 1 is testable with the OCPP version 1.3. But I would suggest that since this is the latest version, I would always update to the latest version of the security white paper and also update to the latest version of the OCPP, so 1.4.
Okay. I think I have some similar questions. What are the differences between edition 1 and 2, mainly around firmware updates? And is edition 2 downward compatible with edition 1?
It's not backwards compatible, I think, especially because of that we have used PEM certificates, PEM certificates everywhere now. So you will probably come into conflict with if you go to edition 1, you will probably run into issues that the certificate format will not work. We also have some field name changes, so it will not be backwards compatible. And the second part of the question was, Martijn?
What are the differences between edition 1 and 2, mainly around firmware updates?
Maybe you can go a little bit into the added firmware update requirements, Milan.
Well, I think that there are not that many changes in the firmware update. I think the main changes are the changes that were also being implemented between 2.0 and 2.0.1. Not all, some of the errata were already included in the edition 1, but the edition 2 is fully in line with 2.0.1, and one of the major changes was the PEM encoding format change. So I'm not aware of the major firmware changes.
I don't think it would change, but mainly added requirements. So, but I will.
Yeah, some additional requirements. We will answer via mail exactly which requirements were added.
Yeah, so maybe a remark in general, in the edition 2 of the security white paper, in the last chapter, we have a changelog where you can see exactly which requirements have been changed and also which have been added and which fields have been changed. So the chapter 9, if I'm correct, or 10 of the security white paper edition 2 lists all the changes between the two versions. So you can see all the details there.
Good one, Paul.
Thank you. Let's see. Will there be an update to the OCPP 1.4? Currently, it is not up to date to latest white paper. Some field names have changed, and tests that require new certificates generation cause internal tool errors.
As far as we know, it's in line, but maybe it's best to report the issues with the tool to via the regular channel, and we can just pick them up when necessary.
Thank you. Let's see. I think we have covered a lot of questions regarding this subject. Let's see. One moment. One more quick question. Which AOX and LOX use cases are necessary for Profile 2 implementation?
For the Profile 2 implementation, you need Profile 2 is the TLS with Basic Authentication. So you need to be able to change the password, so A01, which Milan indicated.
A0, 2, and 3 are not needed. Those are for security profile 3. And security notifications are also required. And that's A04, if I may remember correctly. And then A05 is the change of the security profile level, and that's only needed when you have multiple security profiles installed.
Okay.
And L0, those are the secure firmware is required, of course. Are there more questions, Martijn?
Yeah, I'm looking. I think we can wrap it up. I've got a few questions, but I think you have answered the most. Let's see. Any tool to create client certificates?
Okay, Paul can tell something about how to do this, but what we've done for the OCTT is we created a default package of key stores and certificates which can be used for the testing, and you can also create your custom ones and add the custom ones to use for the testing. But Paul, maybe you can explain a little bit more about.
Yeah, so on the creation of certificates, on our side, we usually just used OpenSSL for creating certificates. So both for the RSA as well as the ECDSH DSA certificates, it's relatively easy to do. We also use those to create the certificates that Milan just mentioned for the OCPP compliance testing tool. So we just use OpenSSL for that.
Okay. Thank you. I think this will be the final question. Is the CA certificate only installed by central system? And is there a message in which the CP can notify the CS the CA certificate is out of date?
Will you use a security event notification if you want to report that it's out of date? And as far as the first part of the question, that was, well, you can have it pre-installed via the firmware already, a root certificate. And after that, the only way to install new root 3A certificates is by the CSMS via the install certificate request.